Got an interesting one here. This Mitsubishi VRF unit has got a COM error, and you can see that relay cycling. And if we look over here, so here's a reference waveform for the what a good COM looks like. All right. If we look at this line here, you can see that the signal is trying to get pulled up, but it keeps dropping down as soon as the unit energizes it. So what this is really indicative of is a short on the COM line, because it can't stay up in its logic threshold. So we're going to disconnect the wires and ohm them out and see what we get. All right, so the central controller COM line is good, but this COM line here that's going from the unit to the indoors, you can see is shorted out, and that's the reason for that cycle. So a lot of times when you get something on a board cycling like that, you've got a short, and that's true of like switch mode power supplies as well. Whenever you see a weird cycle on and off, you're probably dealing with a short. We fixed the short to ground, but I may still have a bit of a COM issue because this unit's faulting out on an error where it's not talking to the indoors. So we've got the indoors disconnected, and we're just connecting them up one at a time. And the first one did really good, but this one, now you have to be careful not to overanalyze signals, because there can be noise and different things. But one of the things that I don't particularly like, so in any kind of COM situation, you've got a logic threshold where your peak has to cross a certain threshold to be counted as a bit, you know what I mean? And what I don't like, you see how symmetric and clean this is? This is our reference waveform. And then I connect up this unit, and look at how these peaks are short, and our typical amplitude is like, you know, 2 volts less on this waveform. So I want to keep that in mind. What I might do is disconnect this unit and connect another unit and go from there. All right, let's look at this waveform. So I've got one unit connected here. I connected the second unit, and that's what was pulling down the waveform, and then I connected the next unit and bypassed that unit. So we're just running the COM line here around into that unit, and now my signal's back up to normal. You can see my amplitude is exactly comparable to my reference waveform, and it's symmetrical. So there may be an issue on that board, especially with like a filter cap maybe, that's pulling down the signal. All right, I've got every unit hooked up besides the problem child, and my COM signal is staying perfect. So I believe that one unit is manipulating the signal enough to confuse the system. And you may be wondering, you know, won't this unit throw a code for no COM? Yes, it will. However, when you've got a signal that's just slightly manipulated or turned into garbage, sometimes those codes aren't helpful because they can jump from one unit to the next. And that's what we were seeing in this case. It wasn't a consistent code. Something also really weird with this board. So the remote wasn't working on this unit. And turns out that somehow internal to the board, the polarity to this remote was switched. So what I should have here is positive 12.3, like on this unit right there. Oh, that's a stretch. My coworker's a giant, so I'm getting him to hold the meter. He can reach clear up to the ceiling. But you can see we have positive 12 on that one, and that remote is working, besides being in an error right now because we have the other unit hooked up. Yeah, something very weird is going on with that control board in the other room. I'm at the branch box now and just got the new board in. I'm kind of bummed out because I forgot to film a really important clip. So I was on maintenance tool and it was kind of chaotic. They were rushing us, and I was also having computer problems, and I just forgot to film that section. So once we got the comm signal back to normal, I got on maintenance tool and I could see that the branch box wasn't talking and the outdoor unit was acting very goofy, like comm wise. So I replaced the outdoor comm board and have replaced this board. We're still waiting on the indoor board, so we're just going to leave that out of circuit because they're really dying to get AC. So let's fire up the system and see if we've got communication, i.e. let's see if it runs. All right, outdoor unit is running. That's a good sign. Got a jungle back here. Indoor unit's running with no code. Nice. She is cooling. Awesome. All right, so after fixing everything else, we just had an indoor unit. So we got rid of all the other codes, and then we had a code pop up that has to do with like interference and stuff. So we've got another indoor unit that's got a bad board. So here's what the signal is like with that unit on the network. Now we're gonna unplug it and we'll look at the signal. All right, we've got the comm lines unplugged on that unit. Now look at this. So my amplitude has gone, I mean, like tripled. So this cursor here is where we were at, roundabouts. And now we're back up to normal. So we're gonna reboot the whole system and see if we can run now. This is just unbelievable. Whatever kind of shit went through these electrical lines, it just did some major damage. All right, I apologize if these clips are chaotic, but this has been a very chaotic troubleshooting mess. Where we're at right now, so we're still having some problems with the outdoor unit, and if you look at these capacitors, that one and that one, they're bulged up and you can see some leakage. So these are bad for sure. High ESR. I went and picked up some new ones, and we're gonna just try to solder them on there. We tried a donor board first. It's an identical board, but I suspect that off that unit, these resistor inputs are different because this board did not, or the donor board did not like being in this unit. So we're gonna attempt a repair on this just to see if we can get them going, because at this point it's just getting ridiculous and we're trying to get this system up and going. I don't think I'll be able to film replacement exactly, but I'll talk about it and maybe show some steps. All right, well, I kind of screwed that up because I did not notice that these are bipolar caps. So what we're gonna do, because these are really hard to get locally, it's hard enough to get capacitors locally anyways. It's amazing we could even find them. But we're gonna put two of these together in series so that we have either the positives facing each other or the negatives. And the way the math works out on this, so here's your formula for capacitors in series. So basically, whatever the total is that you use ends up being about a quarter of the total. Sorry, the total capacitance of these two together, divide that by 4, and that ends up being your actual capacitance. So we're going with like 47s, I think, yeah. And that'll be close enough. All right, I went ahead and did one from start to finish just to make sure it was gonna go okay. So, sometimes these multi-layer boards can be really difficult, and I don't have my Heiko desoldering tool, which is a real bummer. But I cut all the caps off, and now I'm gonna heat each lead and pull it through, and then I'll show you something I do to kind of desolder things without having that vacuum tool. Okay, I've got the pins out, and what you can do is just put some flux on here and go over here with your iron, and it just really cleans the pads up. And then I've got this stainless steel needle. I don't even know, this is just some no-name Chinese set on eBay, but it is a really cool set. So they're stainless steel, and because of that, oh, there we go. You can heat up the solder and put the pin in, and then just twist it and take it out because the solder won't stick to it. So that'll clear your holes. And yes, you can try to heat the back and sort of like wobble your cap in there, but it's much easier, especially for what we're doing, putting 2 caps in series, to have these holes clear. Let me show this real quick. So I'm just gonna heat this pad up, stick that pin in there, and then it dries, and then just spin it out. So that's how we're clearing these holes so that we can get the new capacitor leads in very easily. So now that one's dry, and just spin it out. All right, here's the caps, and you can see I got the hot snot on them. But you can also see why I wanted to use that pin to clear the holes, because with using 2 caps in place of 1, you know, we're kind of crowded here. But oh, this should work fine, besides being very puzzling to anybody that looks at this board. Well, hell yeah, look at this. Perfect, finally. Everything is fucking talking with no error codes. Ooh, man, this was a crazy one. I tell you, I think in total we probably dealt with maybe eight codes. And I rechecked our comm line, and we are still good. I'll play it one more time. There we go. That's a recent capture. Still looks great. Can't make them no promises, but it's working. I am really happy to see that. Ran overnight. Oh man, that's a good sign. We might be out of the woods. Just chugging along. Rid of the jungle. Awesome.